5 years ago, two things happened. The first thing was that I was sanding my concrete walls with my Shop Vac. And that didn't go as well as I did like it to. Now you see the bag in the Shop Vac got blocked up really fast. It didn't really get full, more like the bag itself stopped working. It stopped letting air through it. And this was a huge issue for me. I had a lot of walls to sand. The second thing was that I wanted to become a YouTuber. And this gave me a really good opportunity to become one by simply making a Shop Vac for my needs. So I went ahead and built one. This one. I recorded the whole thing, but I kind of got cold feet and never posted it, so yes, I did solve my first problem with the Shop Vac, but the dream to become a YouTuber was no more. It just gone. But that was then, now is now. And I am a YouTuber, and I do have a video about it, so I'm gonna show it to you. There was a few things I did change about the machine afterwards that immensely improved the performance of it. I will show you that later on. Now, the first thing I did was to disassemble the Shop Vac. It was a really simple process with just a few screws and a little bit of force with a hammer. I measured the depth of the protrusion of this lid thing, and then I transferred that measurement to the bucket where I later will cut it. Now the bucket was made of stainless steel, so it was actually quite hard to cut. It's way harder than I thought it would be. Near the handles I wasn't able to trace with a tape measurement, so I simply just had to use a tape to continue with the line. Now, thinking back about this, I could just have removed the handles, which I did do anyway later on. After I had divided the bucket, the edges was really sharp and I needed to sand them down. But more importantly, where is my face mask? I didn't really think this one through, did I? So next up, I traced the bucket on a piece of plywood. And then I just simply cut out the shape with the jigsaw. Now this piece of plywood is meant to go inside the bucket, but it's a little bit too big. I use an angle grinder to create a bevel on the edge. And then I use a router to gently trim down the edge some, so it will fit into the bucket. I want an exact copy of this shape. To do so, I use a pen to trace the outlines of it. And then I use a jigsaw to cut out the shape. I screw the two pieces together with 2 screws. And then I use a router to trim it down with a trim bit. And as planned, the two shapes are identical. The hole for the old intake needed to be blocked. For this I used a small piece of steel. I first clamped the steel piece to the inside of the bucket wall, and then I drilled through the bucket wall and the steel piece. And then I temporarily insert a pop rivet to keep the two holes aligned while I drill the remaining holes.
It broke!
Because the drill bit broke, I made a dent in the bucket, so I used a hammer to fix it. Now the plywood piece wasn't a perfect fit, I actually made it a little bit too small. To fix that I used a few metal shims between the bucket wall and the plywood. I added some silicone on the small steel piece to make a good airtight seal. I then insert pop rivets in all the holes and squeeze them together to get a good tight bond. Like that. Next up, I need to mount the plywood to the bucket wall. Now to do that, I drill a few holes around the bucket wall, and then I countersink the holes and put screws in them. Next up, I trace the outside of the bucket wall to make a copy of it. And as before, I use a jigsaw to cut it out. I cut it out a little bit larger than the bucket, so I later can trim it down with a router. During this whole process when I build it, I make sure to mark every piece with all possible information I can add, like which side is going up, which side is forward, and so on. I center the two pieces and then screw them together. I wanted the plywood piece to be slightly larger than the bucket, so I added a few layers of tape on the outside of the bucket so that the trim bit from the router doesn't fully reach the bucket. I think I ended up adding something like 6 layers or something like that. And because I did do 6 layers, I reused the same piece of tape and just moved it around as I went on. No idea why I did like that, but it worked. I marked the end of the tape so I know where to stop the router. The reason why I make it a little bit larger is because of the bottom piece that sits on the bucket. It needs to be a little bit larger so it becomes airtight. If it's too narrow, there is a chance that air might leak in. I then trace the whole piece again onto a piece of plywood. And cut it out. I screw them together. I use a router to make an exact copy. Now these two pieces are meant to go on the bottom part of the bucket. And as before, I try to center these two pieces as good as I can and screw them together. This area I want to remove to create a little bit more space in the bucket. It's the middle area I want to remove, so the screws in the middle I can no longer use. Therefore, I screw them together at the edges. And remove the middle screws. And I also remove the edge screws. The screws I add at the edges are screw holes I can then use to realign the two pieces exactly as I have made them right now. The hole I drill I do from two sides to prevent tear out. And my trusty old jigsaw does the job. And here you can see me reusing those screw holes I just made to perfectly align the two pieces again. And then add a few more screws. And there we go. A lid for the bucket. And I trim down the edges to make it look a little bit better. And then I do pretty much the same thing for the top piece. So far the top piece and the bottom piece are almost identical. Here a test so the machine part still fits. Hey! If you like this video, remember to hit that like button so more people get to see this awesome project. Hit it! I'm gonna reuse the hose connection to the Shop Vac. To do so, I need to trim away some plastic from it. And the 90-degree angle on the back of the intake I also remove. On the machine part, I remove a little bit of the plastic to increase the airflow. Later on, I remove the entire ring you can see up there, but that's not in the video. Here I measure where that blob thing is, so I know where to put the Cyclone. The Cyclone must not come directly under that blob thing. I pre-drilled the hole for the big hole saw. And then again, I check the alignment so nothing is blocking the hole. You can even see the remains of the old plastic wall. And that is why I removed it. There wasn't really a manual to do all this stuff, so I had to figure it out as I went along. Here I mark the center of the intake on the Cyclone as well as where it begins. And then I line up the intake and mark it where I need to cut it so it fits together with the Cyclone intake. Because it's a piece of black plastic, it's very hard to draw on, so I use a piece of tape to mark where to cut. And then I remove the burr of the edges. Now the intake of the Cyclone is coming down at a slight angle. I need this to be a 90-degree angle and not as it is right now. And the only way I could figure out how to do this was to eyeball it. I used a 90-degree angle and my eyes to figure out where to cut it. And then to get as straight cut as possible, I use a miter saw. Yep, aligned perfect with the intake. The intake pipe was too low, so I needed to use a tape to get it a little bit higher up. I marked the center of the intake. And of this, I made a lot of lines to figure out where the support pillars are gonna go. I screwed the screws completely through the piece so I can know on the other side where the screws is gonna go. And because of the circular shaped plywood, I need to countersink a few of the screw holes. Like that. And then I screwed it into place. I could have used glue here, but for some reason I didn't use it. Back then was different times. Here you can see me using a laser to get the perfect alignment on the bottom piece and the top piece. And then I mark where all the pillars are going to go. And I do the same thing on this piece. I screw it through on the underside so I know where to screw it from that side. And instead of the tape roll I used earlier, I used 2 foam pieces so I can remove them even though the Cyclone is still there. And it looks good. I use a drill bit to mark where the screw holes are gonna be. These holes are used to mount the Cyclone. And to know where the Cyclone hole is going to be, I need to know the center of it. So I just draw a line between the screw holes. I pre-drill and then I use the large hole saw. And as with all holes you want nice edges, I drill from both sides. Then I add a few screws and nuts on the other side. Now the thing you see me do here is a little bit mistake. I end up actually putting this piece back together. But what you can see me do is that I mark where I want to cut it. And then I cut it. But it wasn't really flush with the plywood, so I mark it and I cut it again. And guess what? It still wasn't flush. There we go. Good job. And then I assemble the whole piece with the holes I have from the screws I made from the other side. Next up, we need to remove some more plastic from the intake. And this is so that we can add screws to it. And then we just screw it into place. To get a good airtight seal between the Cyclone and the intake, I use a construction glue that is called PL600. It's a really strong glue that gets really hard. If there's any place air can get in, I put silicone there. And I reattach the handle. You know, We gotta test so everything still works. It does, nice. There's one thing remaining, and that is to lock the upper piece to the lower piece, so I can separate them when the dust bucket gets full. And later on, I add an inner tube from a bicycle tire around the plywood to make an airtight seal, but that's not in this video. Alright, so that was all I did 5 years ago, at least what I did record. Now let's go to the part that I didn't record and have changed afterwards. Oh, and if you haven't subscribed to the channel yet, do so, and you will get to see a lot more content like this in the future. So this is the machine as it looks right now. It looks pretty much the same, except a few small changes I made. But before I can tell you about those changes, I first need to explain how this machine works. Up here is the engine. That is the part that has all the suction. What this engine does is that it sucks air through this hose into this cyclone, and this cyclone then separates all the dust so that the dust falls down into this container down here, and the rest, well, the rest is pretty much air, gets sucked out up here and out through this filter over here. So that is how it works. But there is one very important thing that just needs to work perfectly, and that is that this whole machine needs to be airtight. There can be no leaks. If there is a leak down here, for example, what will happen is that it will take air in here, the air will grab dust, and the air will travel up through this cyclone and into the engine, and you know, that's not what we want, right? To fix all that, I needed to add this bicycle hose as a sealing, so that didn't happen. Let's take a closer look at that. Alright, so now you got a better view, great. Now this bucket is going up here and against this bicycle hose, and the hose is made of rubber, so it gets airtight, right? And that's about it. So this works really, really good. Now the next thing I have done is inside here. There we go. So inside here I added, oh crap, this is full, I need to empty this one. Just a normal vacuum bag thing, I don't know the English word for it, but this is the part that's normally down in this bucket down here. The reason why I have this bag up here is so that all the particles that the cyclone does not separate goes into this bag instead of into the filter of the engine. And because this is made of fabric instead of normal paper thing, it's reusable, and I can just shake this one and blow it free of all dust and reuse it as many times as I want to. The main suction area of this entire compartment is over here. To prevent this bag to get sucked into the engine or that filter or that little hole, you can see down here. This area over here, so it doesn't just cover up this small tiny area over here. I added the screws here to act like a fence or something like that, so it doesn't, well, go over there, and that gives a larger suction area on this bag. And another change I made here is that I completely removed this entire wall of plastic that was here, and it just restricted airflow. You can see the filter here, by the way, it's very clean. Alright, so that just happened. I wanted to clean up the machine and I kind of broke it. but that gives me an opportunity to show you guys how I did it from the beginning. So you can see down here is that the bag is now missing. I did clean it up, but the thing that had happened was that this little ring that I had attached to it came loose. This ring was over here so that this hole had somewhere to seal tight against. I decided to use these no more nail things that I had at home. Yeah, it works. So let's do this. It's a bit messy, but it's okay. Smear it out. Let's drench it. Then we just force it down here. Removing all this from the inside while lining it up. That should do the trick. I know. This is not silicone, but if it has lasted this long, it should last a few more years. Okay, I put way too much. When this is dry, I can just press this bag over this ring and then use 4 screws to fasten the plate to the plywood. That's it. Now let's talk about the good things this machine has brought me. First of all, we have the dust separation. The dust separation the Cyclone provides is just amazing. I love it. And another good thing is that the added height made it so I can store this tool on it, just like that. I mean, it looks like it was made for this. In the past, this was down here and this long shaft just, wow, it didn't look just right, but it's way better like this. Oh yeah, the footprint. It is tiny. Now, if you compare this with the normal method people use, is that they put the Cyclone and the bucket on the side of the whole shop vac. Now, this creates a footprint that are twice as large as this one. The small footprint of this machine makes it so that it doesn't take as much room in my rather small area. And that's super good. This design is kind of bad for big places. Now the reason for that is it's tall. And when you pull this one up here and it gets stuck down here, it turns over really quickly. And 3 times I've been able to, well, what's the word? Turn it over, floor it, almost damage it. Yeah, something like that. But that is something I prefer over having a bucket on the side. So this machine right now, I think it is the best machine I can possibly get for my workshop. It is perfect for this. It is small, it is compact, it has a Cyclone built into it. Yeah, it's just really good. And it has good suction power.